share the video. You can watch it to understand the project description and then what features are there, everything, because this has already been trained to our students, in the previous sessions. Okay. So these are the things, right? Next, what I will do, I'll straight directly jump in here. So in this case, you can see the bias variance trade-off. This for example. Okay, the bias is the blue color is your bias. As the model complexity increases, this is the one goes up. The sweet spot is somewhat here. Okay, that's what the variance and something. That means you can reduce it. You can this is your sweet spot. Okay, with this you can achieve the right balance between that and this. And next one is I train my random forest model and then the learning curve also I plotted it here. Okay, one second. So in this case, if you see this one, I trained my random forest machine learning model. And when I plotted it, I could see that the distance between the training accuracy and the validation accuracy, the orange color, this one is your test data score and training data score, the distance is too high. With this also, this is called your learning curve. With this learning curve plot, you can make out quickly, hey, this model is overfitting. This is another way of finding out whether your model is overfitting or underfitting. Uday Kumar, where is social dropped out? Okay, you was little bit confused because of he did not attend my previous session. Anyhow, don't worry. Okay, and similarly the XG boost algorithm, random forest and XG, both of them are not performing well. And when I executed that script here, it should show that right training accuracy. Previously, one second, I just show you here my look here in this case when you just think don't worry about this script. Okay, this is a random forest algorithm, that's all. Okay, I just clicked the run button here. I could see that my training accuracy was 1 and text accuracy is 0.79, so the difference is too high, right? One is too good, but when I apply my model on the unseen data test data set, what happens? Just 0.80 only. There is a too much of difference between the training and test data set accuracy. Okay, so hence with that itself we can conclude that the model is overfitted. Okay, now this even for both random forest and XGBoost, when I like I said Uday Kumar, right? Uday Kumar developed random forest as well as the XGBoost machine learning models using the his own data training data set. And when I asked him to, test it with my two different data set using these two algorithms, it is not performing well. Hence, it is called overfitting. Both random forest as well as XGBoost overfitting. So how do I fix that? So how do I fix that? Okay, before that, I know, can I visually see this one? Yes, that is what we plotted it here. So it is very clear the training accuracy and test accuracy is too far. Okay, with that itself, we can make out quickly it's not performing well. And now what I did something here in this script and I have included some hyperparameter. I did some kind of hyperparameter tuning. Using hyperparameter tuning also, you can reduce the error here, right? Use an hyperparameter error also. What I did, I was able to generalize my model well. Both the training and test data set accuracy is somewhat close by 0.86 is somewhat close to 0.80. Okay. So I fixed my random forest, the overfitting issue, and similarly XGBoost also I fixed it here 0.85 and 0.80. Very good. Somewhat close by. Both the training and test data set. SVM views hyperparameter. Yes. Okay. So usually, right, the case of random forest XGBoost, we'll be using yeah, correct. You can use it there also. Even neural network also we can use it. So here basically what I did, I used different hyperparameter. Important the learning rate. I gave a very small value, and hence, right, it is kind of doing well with the combination of what is n estimators number of trees, 100 trees, and in the case also 100 maximum depth of the trees 10 and 5. I reduce the maximum depth, right? So in this case, and minimum samples 10 and sample split and random state, not the random state, regularization lambda equal to 1. So in the case of XGBoost algorithm, it uses L1 and L2 regularization. Okay, and the case of random forest, it uses the bagging technique to do the implicit regularization. This is an explicit regularization. Okay, but again, in both the cases, the regularization is done implicitly. Okay, HCB classifier. I will explain your regularization. Don't worry. Okay. Okay, how to address this one? I will share the script also to you all. You just play around. Look here, in the case of XG Boost, my training accuracy is right further I increase 0.89 and 0.80, somewhat close by. XGB classifier, I could see that I reduce the number of trees to avoid overfitting and maximum depth, right? All the things. These are called your hyperparameters. The interview they'll ask you, can you please tell me the name of few hyperparameters that you used in model? And the next question is, how did you fine tune your hyperparameters? You can say you use the grid search CV, or you can say randomized search or Bayesian search. Okay, but grid search CV is in general it's too slow. It takes longer time to find out the optimal number of values for each hyperparameters. Randomized search is a bit faster compared to grid search CV. And apart from this, we have something like Bayesian hyperparameter. Okay, so sorry, Bayesian search. Okay, Bayesian search takes compared to all the two like grid search and randomized search CV. Bayesian search is pretty faster. But thing is right. Sometimes Bayesian search may not be that accurate or it will not be good. So anyhow, we'll discuss about all these different types of parameters, hyperparameter tomorrow session because you need to practice all the things. But guys, what I do is I'll share this one. You can download it and then simply execute each and everything. Okay, but make sure that you have the data set which I will be sharing it or already shared it, right? You keep it in your laptop and then you need to specify the correct location. This is the where you need to specify the correct path where you download. This is what my file name. Okay, this is what my file name. This file you keep it in your download it in your laptop and then put it in some folder. Whatever the folder that whichever folder you kept it there, you need to specify that folder name along with this file name. That's all. The rest of them will work. Simply click, it will work, it will work. And here what I do is I will probably put something like 1 second. I will do it right away. Pip install because xtboot will not be there by default. So this command will install the xgboost package. And then if you execute the rest of the thing, it will work fine because the rest of the things, packages that are available by default when you install your Jupyter notebook or Python. Okay. Fine. So we discussed a very important concept. And these are the precursors to understand the hyperparameter. That's the reason why I started with this one. Next, we will jump into the hyperparameter in tomorrow's. That's very, very important. But most of the time, when we worked on the complex real-world scenarios, really by tuning the hyperparameter, we're able to boost my model accuracy like anything. Okay. That trick I will teach you tomorrow. Fine. So, any questions so far? Yes, tomorrow we will discuss that, and followed by that, we'll discuss about the neural network also, Priya. Tomorrow and day after tomorrow, we'll continue the neural network. We will finish up everything and do. Next, what we'll do is, okay, next, what we'll do is uh, we will continue on this upcoming Tuesday, okay? And tomorrow and day after tomorrow, we'll have session, and this Tuesday, we'll continue the session. The Tuesday we will continue with the most likely on the Gen AI. Okay, if everything goes well, let's know if I complete neural network, Gen AI will start. That's a very hot topic. Okay, who asked this question? How much? What is your say? I'm working as a data science architect, Uday Kumar, with a leading retail giant in Bangalore. Okay, fine, guys. Since you don't have any questions, I'm going to wrap up the session. See you all in tomorrow night. Okay.